Okay, this lesson is going to be on section 2.5 from Foundations in Precalc 10, and it is using the sine and cosine ratios to calculate lengths. In this drawing, which I realize you probably can't see on your copy, you can see that the person or the survey team has got a survey pole across the pond, and on this side of the pond or lake, they've got a transit point and a survey stake. And if they take the measure of the angle between the transit and the survey stake, and they've got the distance to the survey stake, they can use math, use trigonometry to figure out how far it is across the pond. So this is an example of where trigonometry is used. I'm not going to actually do that example, but that's how you could do it. So here's an actual example. It's very similar. For example 1, we're going to use the sine or the cosine ratio to determine the length of a leg of our right triangle. They've asked us to find PQ, which is this one over here. I'm going to label it with a lowercase r because I like that convention. It's less confusing than the PQ. And I'm going to write out the little trick I showed you. So, katoa. And I'm going to circle what I know. So I know my angle, which means I effectively know sine and cos and tan, because that's just a button on my calculator. And I know the hypotenuse of this triangle, so I'll circle the h's. And I'm looking for the opposite side, so I put a box around the o's. And so we have 2 knowns and 1 unknown, so that's the equation we're going to use. So we'll write out the base equation of sine theta equals opposite over hypotenuse. And then we plug in what we know from this situation. So sine 67 equals r over 10.4. Then we need to just use some algebra to solve for r. So we're going to multiply this side by 10.4, which cancels out. We're going to multiply this side by 10.4. And we then have 10.4 sine 10.4 sine 67 equals r. We don't need to put a time sign or brackets to indicate that this is multiplication. You just need to know that it's multiplication, just like if it was a number beside a variable, it'd be multiplication. And then we get our calculator, and it tells us that r equals 9.57. And the question asked us to the nearest tenth of a centimeter, so we are going to say PQ equals 9.6 centimeters. And we need to ask if that is reasonable. So we need to look at the angle and say, does that look like a 67-degree angle? Yes, it does. So if this line, if the hypotenuse is 10.4, does that line look like 9.6? Is that a reasonable number for that? Yes, it is. So we're done. All right, for example 2, using sine or cosine to determine the length of the hypotenuse. We are looking for side JK, which I'm going to label as lowercase m, because it's across from the letter M. And I'm going to do the trick with the katoa. And we know, since we know the angle, we effectively know tangent and cosine and sine. And we are given the opposite, so we can circle the O's. And we are looking for the hypotenuse this time, so we can box the H's. And we are going to use sine for this one as well. So basic equation, sine theta is opposite over hypotenuse. Plug in what we have. Sine 65 degrees is 7.6 over m. Now the algebra on this one's a little more complicated because we need to get rid of the fraction first. So we're going to multiply both sides by m. And so we have m sine 65 equals 7.6. and we're going to divide both sides by sine 65, sine 65, and then it's just a matter of plugging that into our calculator, and we get m equals 8.3857. We were asked to do that to the nearest tenth of a centimeter, so m equals 8.4 centimeters. Put a nice box around it, or actually let's label this JK. Is that reasonable? Does that look like a 65-degree angle? Yep. And if the long side here, the opposite is 7.6, is 8.4 a reasonable measurement for m? Yeah, I would say yes. Okay, on to example 3. Solving an indirect measurement problem. From a radar station, the angle of elevation of an approaching airplane is 32.5 degrees. So let's make sure we understand what's going on by looking at the diagram. So there's our 32.5 degrees. The horizontal distance between the plane and the radar station is 35.6 kilometers. There we go. How far is the plane from the radar station to the nearest tenth of a kilometer? So that we're looking for this distance. Okay. I'm going to redraw the drawing so I can label it with some letters and numbers. So that's 32.5 degrees. That's this angle here. This is 35.6, and let's call this D. And we're not sure what we need to use, so let's go katoa. Now, we know the angle, so we know sine and cos and tan, and we know the adjacent, and we are looking for the hypotenuse. So this time we're going to use cosine. So base equation, cos theta is adjacent over hypotenuse. Cos 32.5 is 35.6 over D. So we need to multiply both sides by D to get rid of the D in the denominator. And then we have D cos 32.5 equals 35.6. So we now divide this side by cos 32.5 and divide this by cos 32.5. And we are left with D equals, we use our calculator, and we get 42.21. The question asks to the nearest tenth of a kilometer, so distance is 42.2 kilometers. And then we have to go DIMS. Does that make sense? Does that look like a 32-degree angle? Yep. So if that's 35.6, is 42 reasonable for that distance? I would say yes. So there's our answer. Okay, so short and sweet.